Hello there, hope everyone is doing well and staying safe. In this video, I wanted to go over how machine learning in artificial intelligence works at a higher level and help in understanding it. So let's get started. Before we dive into how machine learning works, let us first define what machine learning is and how it fits within the realm of artificial intelligence. So let us start with defining artificial intelligence in a quick manner. If you are interested in a bit more high-level explanation of what artificial intelligence is, I'll have the video down in the description section down below. So in a quick manner, artificial intelligence is an umbrella term that encompasses a wide range of technologies, methodologies, and applications aimed at creating machines or systems that can perform tasks that would typically require human intelligence. And a brief definition of machine learning would be that machine learning is a broad field that encompasses algorithms and techniques enabling computers to learn from data and make predictions/decisions without being explicitly programmed. In essence, machine learning algorithms allow computers to recognize patterns in data and make informed decisions or predictions based on those patterns. Now that we have an understanding of what machine learning is in correspondence with artificial intelligence, let's start out with an example of a machine learning application. Let's say you want to go ahead and build an image recognition application. How would you get started? Well, there are a couple objectives we have to fill out first prior to getting started. For example, to get us started, what machine learning model should we choose? Well, that's great stuff, code, but what is a machine learning model and why should we start there? I am glad you asked. A machine learning model is a mathematical representation or approximation of a real-world process that is learned from data. In simpler terms, it's a set of algorithms and statistical models that computer systems use to perform a specific task without being explicitly programmed for that task. Machine learning models can be categorized into different types based on their learning approach, such as supervised learning, unsupervised learning, and reinforcement learning. They can also vary in complexity from simple linear models to complex deep neural networks. Overall, a machine learning model serves as the core component of a machine learning system, enabling computers to learn from data and perform tasks that would be difficult or impossible to accomplish with traditional programming approaches. Okie dokie. Now that we have covered what a machine learning model is and why we need it, let us take a look at some of the more popular models regarding machine learning. First, we have a simple and commonly used model for regression tasks called linear regression, where the goal is to predict a continuous target variable based on one or more input features. It fits a straight line, or rather a linear equation, to the data to minimize the error between the predicted and actual values. Next up, we have logistic regression. Even though, despite its name, logistic regression is used for binary classification tasks, where the goal is to predict one of two possible outcomes. It models the probability of a binary outcome based on one or more input features. Next up, let's take a look at decision trees. Decision trees are tree-like structures where each internal node represents a decision based on a future, and each leaf node represents a class label or a continuous value. They are versatile models used for both classification and regression tasks. Well, cool beans. Next, we have what's called random forests. Random forests are an ensemble learning method that constructs multiple decision trees during training and outputs the mode of the classes, or rather classification, or the mean prediction regression of the individual trees. Makes sense. A forest is made out of trees, so having decision trees makes up a random forest. Okay, I'll stop with the jokes. Next up would be a model named neural networks. Neural networks, particularly deep neural networks, are a class of highly flexible and expressive models inspired by the structure and function of the human brain. They consist of interconnected layers of neurons and are capable of learning complex patterns from data, making them suitable for a wide range of tasks, including image recognition, natural language processing, and reinforcement learning. There are a couple more models that we can go over, but I think I will just list them out on the screen. Now that we have covered some of the more popular machine learning models for our image recognition system, I think we would have to go with neural networks as our primary model, and we can expand that with deep neural networks such as convolutional neural network. The main reason for the selection would be what's called a domain-based experience regarding the problem we are trying to solve, and that would be image recognition. Okie dokie. Now that we have our model selected, well, how are we going to utilize it? Well, this is where gathering data comes into play. For ease of the image recognition example, we are going to assume we'll be using existing datasets that are available online. These datasets need to be what's called labeled data and falls under what's called supervised learning. Well, that's great stuff, code, but what is supervised learning? I am glad you asked. Supervised learning is an algorithm that is trained on a dataset that consists of input-output pairs, where each input is associated with a corresponding output or label. The labeled dataset provides the algorithm with examples of the correct outputs for given inputs, enabling it to learn the relationship between the inputs and outputs. So it means that in the training process of the supervised learning algorithm, the learning process comes from the labeled examples in the training dataset by adjusting its internal parameters or model structure to minimize the disparity between its predictions and the true labels. Okie dokie. We have gone over quite a bit of stuff, so let us do a quick review to see where our current process is. First, we started out with selecting our system's purpose of image recognition. Afterwards, we have gone through different machine learning models and selected our machine learning model that we will be utilizing for this process. Next, we talked about the datasets and how we are going to be using an already existing labeled dataset that falls under the supervised training method. Alright, let us move on to the rest of the machine learning process. The rest of the process is going to include the finalization of the machine learning system. So let's get to it. Next, we are going to be taking a look at evaluation/validation of our process. This means that either we have another label set or we split our dataset into training, evaluation, and testing categories. In our case, we are going to be doing what's called a train test split, where we split the available data into two sets, training data and testing data, where we are going to train the model on the training data and evaluate its performance based on the testing data. This method provides a simple and quick way to estimate the model's performance, but it may lead to what's called overfitting, which is the model memorizing the training data if the testing set is too small or not representative. Once we have determined our selection of training data and testing data on our train test split and executed its run, the next step would be to fine-tune the model we have selected based on the evaluation results. The evaluation and validation process can take a bit of tinkering with the data, and other internal adjustments to the model might require. It is important to understand that the percentage of accuracy you get may vary from quality of your dataset. This is why using a highly curated dataset can make tons of quality changes. If the dataset is noisy, incomplete, or biased, it can lead to suboptimal performance and lower accuracy. Issues such as missing values, outliers, and class imbalance and label noise can negatively impact the model's ability to learn meaningful patterns from the data. Once you feel your machine learning model has been trained enough with good accuracy results, it's time to finalize and get ready for continuous improvement of the model and the dataset. Basically, at this point, it's up to you to gradually improve your system and expand on its concepts to see how accurate it can get. Now on to the summary. It was quite a journey, but I think we have covered how machine learning works at a higher level. First, we started out with selecting our system's purpose, of which, for our example's case, we went with image recognition. Afterwards, we have gone through different machine learning models and selected our machine learning model that will complement the image recognition system. Next, we talked about the datasets and how we're going to be using an already existing labeled dataset that falls under the supervised training method. Afterwards, we have then talked about evaluation and validation to whether the dataset we have is accurate enough or if we need to fine-tune it a bit more before we finalize it and get ready for continuous improvement of the process, where we feed even more datasets to increase accuracy and variety of the recognition of the system. And this can only be done with numerous data, in our case labeled image data. Remember that the machine learning process is an iterative process where we have to apply continuous improvements to our system and adjust its data to make sure its accuracy doesn't fall off. Thank you for watching my video. If you like this video and would like to see more, please don't forget to subscribe and hit that like button. If you have any questions, suggestions, or just want to say hi, feel free to comment down below. Thank you for watching and hopefully see you soon.